Hello everybody, I'm glad to be here with you today to present some research of our team. The team members are listed here on the slide. So what is this research about? It's about COVID-19 and more precisely how to measure the speed and acceleration of the pandemic. Why do we care about that? If we go back in time, in March 2020, everybody of course was surprised by the pandemic, and one of the first reaction was to try to understand how fast the virus was spreading. If you think about the standard definition of speed, you would think about the position of a car as a function of time. But the problem is with the pandemic, it's not the correct definition, in the sense that to observe the position of the virus, you have to test people, you have to perform diagnostics, and therefore you want this to be your unit of measurement. So that's the purpose of our work here, to measure viral speed and viral acceleration, taking into account the number of tests. The challenge here, if you want to take account of the number of tests, is that it's moving over time a lot. That's what you see on the bottom panel on the left for France over a given period here. The number of tests performed each day in France has been varying a lot, and that's the case also for most of the countries. So our acceleration index is one way to control for those tests and the fact that they vary over time. Essentially, the reason we call it an acceleration index is that you can think of it as the ratio of the speed of the virus divided by the current speed divided by the average speed of virus circulation over the entire pandemic. And that's the object of the decomposition here on the left panel. And on the right panel, you see the acceleration index over time, again for France, which you can think also as an elasticity, basically, of cumulated cases to cumulated tests. So of course, if this index is above 1, it says that current speed is larger than average speed, which indicates acceleration. And in the reverse case, if it is below 1, it means that the current speed of the virus circulation is below the average, which indicates that the pandemic is somehow under control. So why do we need the acceleration index? Well, because the reproduction number that is used by epidemiologists does not control for tests. It's based on positive cases only. And as you can see in the graph here, there can be large discrepancies between our acceleration index, which account for tests, and the reproduction number. And that was the case in France over the summer of last year. A final point I would like to stress about our acceleration index is that because it's data-driven, it's easy to compute it in real time. You only need the number of cases and tests over per unit of time per day, for instance, and you can apply it to understand how the dynamics of the virus varies across groups, across geographical units. And here, that's something we are doing right now. We are trying to understand how fast and what is the acceleration of the virus depending on vaccine status in France. And we find that even though viral speed is larger among the unvaccinated people, acceleration is about of the same order of magnitude at the end of August. That's where the data ends. If you want to know more about all these aspects in more details, of course, you can read the papers that are listed in the final slide. And I thank you for your attention.